Oh, okay. So I'll apologize one more time for coughing. I will be muting myself.
No problem.
I was thinking maybe like we could work on your computer, on your screen with screen sharing.
Oh, I was thinking that maybe we could work on your computer.
We can't. The only, Jesus Christ, the only.
You're making me cough. The cough contagion. Oh no.
I was only thinking about you only because you sort of like I think the in general terms it will all be something around key storage module, right? So you probably are familiar with
The power box will be in the node.
Primarily what I wanted to do, I mean, the idea that I had behind this programming session, which became a huge meeting apparently, was that we sort of like try to think in terms of interfaces of API and how those things will collaborate, not necessarily providing implementation, just the traits that will do the scaffolding.
Right. It's still the power box is going to be something that's in the node code base. Yeah.
Won't you need to add support for doing that kind of thing to your storage library, though?
Well, one thing you could already see is that, like, if you can't produce and consume until I give you an LMDB store. So the instantiating the LMDB store part of things, that can already be in the power box, and then consumers of the library have to be granted the LMDB store. In regards to like the stuff with system processes, there is a need for doing like tagged continuation work, right? But for today's purposes, I don't know that we necessarily need to go down that particular rabbit hole yet. I think from what I've understood talking to Pawel is that he wants to understand the general sort of architecture and interfaces for like the power box, instantiating the power box, and like where we put the capabilities for doing console printing, and the capabilities for doing network communication, et cetera, et cetera. So
like we can even go with like a feature, right? Like even with the channel for standard output.
Yeah, sure. That seems like a perfectly reasonable approach.
And I don't want to implement this. I like the core implementation. I'm more like I'm interested like how things gonna interact, where power box gonna be instantiated, how it's gonna be sort of like communicating with the like interpreter, all those little things. So that's
I mean the naive answer is like node main. Yeah.
But so I mean we can work on my computer. It's just gonna be it might be a situation where you guys will be telling me what to basically do.
I think
so. I don't see how this can get off the ground without tagged continuations in the tuple space.
Well, are you saying that that's a prerequisite for even having it like a sort of discussion here?
Well, I mean, we can talk about it, but like you're not going to build a power box without that.
Okay.
Well, what? Sorry.
So you're saying that in order to move forward, I need to implement this feature right now?
Well, no. So the power box is something that Roland contracts get a hold of. So you could view it as like a private name or multiple private names. But basically what you're doing is you're preloading the tuple space with some private names and some system processes that are listening on those private names. And then you then certain contracts get a handle to that when they start.
Mm-hmm. No, I understand that.
I guess we could work on preloading the tuple space with things that weren't like that. Just you put stuff in before anything started.
like, can we just imagine that we just starting implementing this and let's start writing some code? Like, what would be in main? I just don't have the picture. I don't have the clarification of how that's going to work. And once we start writing code, it doesn't even have to compile yet. Just knowing like what's the idea behind it, how this is going to work.
So what'll be in main is you'll preload a bunch of things into the tuple space. A bunch of like FFI, if you want to think about it like that. So you'll, like, for printing to standard out, you'll register that into the tuple space, so at some unforgeable name. And then processes that get to write to standard out or contracts that get to write to standard out get invoked with that name available.
Yeah, I understand the theory. I just want to write the code so I know how that works. I don't see all the objects, how they interact. Like, I don't understand how the evaluator works, how the developer works. I don't know what type of space is instantiated. I just, like, if we start writing stuff, it will all.
Well, you can go look at how the evaluator works.
I just cannot really talk right now.
Okay.
So why don't we walk him through how you instantiate, because there's code right now to do that.
Yeah, let's do that.
Let me just check out a new branch over here.
Could you lead the way? I really have to mute myself. I'm coughing every 5 seconds.
Okay. 1 moment. I just have to get a branch set up for this.
So Kyle, one thing I was mentioning on the, I think it was on Node channel, is that the idea behind how Node was previously created was that the COM module was bringing sort of logic to instantiate peer-to-peer network. So within main, in Node, the only thing I was doing was I was running this code. Like, so it was returning some recipe of how that should interact, and I was running this with a final effect, which is basically a either TF task. And I was in main, I was just providing the instances for type classes that the peer-to-peer network needed. So like there was like instance for encryption, some other instance for logging and stuff like that. And the REPL staff is sort of copy pasted to Node right now. So the same code lives in 2 places, in the CLI, in Rolang, and right now in Node. And I was thinking, can we do something similar? Like the REPL is just a function that returns you a sort of like recipe to run the REPL, closed over some effect. It could be task, could be something else. And we would just instantiate that in Node. So like this whole thing is in 1 place other than 2 places right now. We have similar code in 2 different places, right?
Yeah, that's fine. It needed to work.
Yeah,
so I made it work.
Yeah. I'm just saying, like, we could do it this.
Sure, mail me a PR.
Yeah.
Dum-ba-dum. All right. Sharing screen, guys. So we want to look at the evaluator first?
Well, go look at like the rolling CLI main. I think
We'll do it
Pawel didn't understand,
Mm-hmm.
or from the node.
Okay.
Like,
yeah, that's the thing. Like, even right now, we see we have 2 different places where we could go. And so
yeah, I agree.
Yeah. Okay.
REPL. Oh, I see. So REPL here. Is the font size okay for everybody?
Yes.
All right. So Pawel, What was your question?
It's not really a question. I would just like, let's imagine we want to implement the power box here, right? So what would be the first step? Like how would that work? Or maybe let's walk through interpreter. So I just know initially what.
So you would make a change to build store. That is all.
Let's look at build store. Down there. It's funny that Ken put these serializers at each place that he instantiated it. Okay, so the idea here, yes, maybe what we'd do is we would say, like, here we would have the store, and we'll still return the store at the end.
And then we would preload the store with PowerBox
right
stuff.
Here, we're going to say preload the store with system processes, right, as they're known, aka PowerBox stuff. So, like, we have these main verbs from the store available to us, from our space, I should say. Just go ahead and wildcard that. I know it's ugly. Sorry, guys.
It's all right.
So, for example, what we're going to do is we're going to be doing consumes on the store that we have. And we're going to have some list of channels for standard out channels. And right now we'll make that a list empty of, what's the Chanel type channel? Very good. Okay, so there's our standard out channels. What's our patterns?
They'd probably just be variable, or they'd probably just be like
the channel is part of Roland. It's a concept from
channel. You're saying so there's seeks of channels right now. Yeah. The patterns, these are Roland terms. Yeah. And then this is the tricky part here, is that now instead of putting a par in, right, we're going to be
remember that I don't know what the par is. I haven't seen the API store. So consume is what exactly?
Do we need to go open up the proto and walk him through this? Because we need to be able to say things like par and have Pawel understand what a par is.
Yep. Let's do that. For now, I'll just say par default instance, but this isn't going to be a par. And we're also going to be putting the persist flag to true, I assume.
Yeah, I mean, you can preload the PowerBox with whatever you'd like, but a single-use print is probably not what you want.
I mean, you know, maybe for very specific client purposes, we want to restrict our clients to only being able to print once. Could happen, right? All right, so to the protos for over here in models, we have essentially the protobuf, the types for Roland. So this is a par. And when we talk about a Roland continuation, this is a Roland continuation consists of.
At least for now. Eventually, that'll be par and an environment.
Right. So now.
So what does it represent? It continues. So is it like a process?
Yeah, this is a Roland process.
Mm-hmm.
How familiar are you with Roland itself?
Pretty much. I definitely with raw calculus and Roland, I think it's a little bit different and some syntax issues, but Roland, I'm familiar with.
Okay, so par is collects all the things that are running in parallel. So if you have A, par B, par C, then par holds all of them.
Okay. So how is that implemented? Like send, receive, all expression match.
These are all data constructors.
Okay, so this is like this allows you to sort of represent processes which are evaluated in parallel, like sub processes.
Yes. So in Rolang, if you have A par, B par, C, they all get rolled up into one par object. And if you have a single term, it still gets a par object.
Okay.
So if you look, like a channel is either a quoted process, which in this case is par. So like there's no like one of or anything like that. It's just we quote a par, and then the par can hold one or zero or more things.
Mm-hmm.
So there's no special process for nil either. It's just an empty par.
So if I have a piece of Rolang that reads stuff, and so let's say I have a Rolang expression that sends some, like has two sub-processes which run in parallel. One sub-process is sending a message over some channel, and the other one is reading that message over the same channel. How that would be represented? That would be par.
You'd have a par,
yeah,
and the send would be non-empty, and the receive would be non-empty.
Mm-hmm.
Okay, okay, got it. Sure, I see it.
So when they interact with the tuple space in the Rolang interpreter, they're putting these
It's co-op.
Yep. And I guess reduce.
Yeah, it's reduce.
Yeah. So if you, for example, like they wrap my consume here, but it's essentially the same idea. You have, you know, this list of channels and channels pattern pairs. Yeah. And then
so seek of channel is a pattern because we have arity matching.
Oh, right. This is right. So it's a list of pattern channel pairs and a continuation here, and they put that in the store. Can you hold on 1 second, guys? I have to take this call real quick. I'm sorry.
So Kyle, if I understand it correctly, like what do you store in storage or whatever the new name is? For example, when you do so consume represents sending or receiving? Receiving. So okay, so I'm saying that I'm waiting for messages that will arrive on this channel, and that on this channel is represented by the sequence of channels, that pattern, right? Sequence of channels is a pattern that represents like whatever message or whatever channel I would like to hear.
No. Okay, the quote is the channel, and then it's unfortunate. It's not perfectly clear. Seek of channel is the pattern, so it says what you're waiting for.
Why is it a sequence of channels, not a single channel?
Because it's arity matching. So if you send, so that like function arguments, every send has basically a count, and you don't match if the counts don't match.
I have a count for what?
You send in. So let me see if I can make this clear. Every send, you send one or more thing.
Okay.
And every receive waits for one or more thing, but the number of things you're waiting for has to match.
I see. So I can have something that represents receiving, saying like I'm waiting for a message on this channel and on that channel, like a channel X and then channel Y.
That's true, but that's not what I was talking about.
Okay.
What I'm saying is, if you have a contract with 3 arguments, that's what there will be 3 things in that seek. And then the quote will be the name of the contract.
Okay. Quote will be the name of the contract.
And then if you don't send 3 things on the channel, the contract will not get invoked.
You say send 3 things on the channel, but couldn't that be different channels? I don't.
Henry,
Okay.
can you open the Roland grammar?
Sorry, guys. Yes, I can open the Roland grammar.
Because I don't think Pawel's getting this. It's in BNFC under Roland.
Mercury.
Yeah, open that one up. Okay, go to psend. Okay, name send list of process. You send a bunch of stuff all at the same time. It's not like a replicated thing, or you like send one thing and then you send the next and then you send the next. And then if you go down to receive's a little harder. It's under receive bind.
Oh, I understand. So you have an RT of, I understand. So it's not like you're particularly matching that somebody sent 3 things at the same time, not 2, not 1.
That's right.
Okay.
Receive bind.
Yeah, linear bind simple.
Oh, I see.
So, and then similarly, like, you have a list of names because there's an asymmetry on purpose. When you send processes and you receive names, there's a reason for this, and that's that if you're sending data around all the time, you have to mark it on one side of the send receive pair, and if you're sending names around all the time, you have to mark it on the other, and it makes it like be out. What?
I think I lost you at the end.
We're just in terms of like the visual prettiness. It spreads the ugly out equally over names and processes because you have to mark them on one end or the other.
Okay.
One second, guys. My screen share will be right back.
Okay.
Just had to tweak something. All right. So we've dug in a little bit here. If we want to zoom back out to the sort of like, the main 2 actions that Roland is using to communicate with the tuple space, with our space, is our produce and consume. Are you okay? Do you understand what produce and consume do right now?
So basically, consume will try to reach for stuff from storage, while produce will push it in, and like both of them will act. So body is continuation. Is that correct?
Body in consume is the continuation. That's correct. Yeah.
Okay. And does produce has body? No.
No, produce only has data.
Doesn't make sense. Yeah. Okay.
At a particular time.
Yeah.
Right?
Okay. And those consume and produce basically consume and produce on storage side.
Mm-hmm.
What's the new name of storage project? I forgot.
RSpace.
RSpace. Okay.
Or RSpace.
Okay.
So the idea here is something like if they're going to be producing and consuming on special channels, and those special channels will be the system process channels. And so part of the idea is that when that happens, there's going to be no longer will it just be pars being trafficked in the sort of evaluation machinery, right? that now instead we're talking about some tagged continuation type. And so one of these tagged continuations is we have a Roland continuation. Another one we'll just call like a Scala continuation. In the case of the Scala continuation, we won't probably actually put the real Scala continuation in the store. In fact, we won't put this. I won't say we will not put the actual Scala code in the store, right? Instead, it will just be it will be dispatched to a lookup table to say, okay, if I get a Scala continuation that's marked as this, what do I do with this? Right? Does that make sense? Yeah.
Yeah. So it can be like a function or something, right?
Right. So Kyle, am I right that like essentially we're looking at wedging this notion of a dispatcher? I think I saw a whiteboard drawing photographed from the Pyrofex offices, and one of the components in this new model is this notion of a dispatcher, right? And so upon doing a consumer produce, I guess in the case it's when we're getting back that continuation, the continuation, it first goes to the dispatcher, right?
Yeah. So right now, so you want to leave the RSpace library like kind of with the API as it is, where like you just assume that the user knows what to do with the continuation. Because
Right.
I think that's the best model. But in this case, if you have various kinds of continuations, then you'll need some way of saying, okay, like take the continuation and evaluate it, but the evaluated part can be like a separate module if you'd like.
Yeah, I was wondering about that because I saw there was two ways we could handle this. One is that we sort of like have the sort of evaluator / continuate or dispatch evaluator / continuation runner as like a separate component. Another could be that the dispatcher was something that we instantiated separately and handed to the constructor of the interpreter, and that we would sort of wedge it in, so to speak, like somewhere in here, so that when you got this continuation, this tag continuation, you would like dispatch, you could say like res here, and so we would dispatch the continuation and the data list. And
so yeah, if you go look up at produce, or no, at the eval of receive.
The eval of receive down here.
Yeah. Well, I'm not sure exactly where it is, but if you just like the eval there's a bunch of eval functions. Like that's the one for variables that your cursor's on. There's one for receive. So if you go look at that.
Okay. Yep. There we go.
So if you look at that line that says continue.
Down here. Mm-hmm.
Yeah, that line would have to be like dispatch, right? Like if it's a par, we just evaluate it. But if it's something else, well.
So yeah, okay.
So all of that is flows over tasks. So dispatch could just return a task, right?
What does this return right now? Task of unit. So yeah, I can return a task of unit.
Why are you laughing? Like,
well, it's just, I mean, it's effectful code any way you slice it, any way you slice it or wrap it. But yep.
Yeah, I agree. Like, the burden of I/O, right? But yeah, so I think I almost got it all. Just to clarify when I'm wrong. When you have the interpreter and sort of like reduce Scala is the whole interpreter of the language. Like it seems like it, right? It has all the evaluate methods for all the elements from the language, like for pair, sending, reducing. So
well, it uses a bunch of things, but like in terms of the actual driver, yes, it is the evaluator. That's one of the reasons I wanted to write an interpreter is because how many lines is this? 500?
Yep, about 500-ish.
a bunch of other things that are longer that we needed to make this work, but we need those anyway.
Yep. Okay, so so to get it right, if I understand this correctly, like without without system channels, right? Without them, when we instantiate the interpreter, the tuple space is empty, and the only way for the user to sort of send the message or receive the message, he has to create a channel by sort of quoting a process, right? So he creates a new channel by quoting a process, so then he can write some simple program like, let's say, send hello message and receive that hello message on the channel. Is that correct? But what we will do, the change that we want to provide here is that when we instantiate tuple space that will be provided to the interpreter, we will instantiate it with some channels which will be unique, and they will be uniquely identified, and one will represent, for example, standard output. Some other one will represent communications. Correct?
So uniquely identified is the wrong way to think about it.
Okay.
Because that's not what we want. So one of the things is, if you just say, like, well, if you quote the string standard out and you write to that, we just write to standard out. The problem with that is that any process can produce that. And so that means you have an ambient authority. The whole point of doing it as a power box is that you can choose which processes get a handle on this. So you, instead of putting them at well-known names, you'll actually put them at unforgeable names.
And how do you do that? Like, how? What do you mean by unforgeable? And how you would achieve that?
So there, go back to the grammar.
Mm-hmm.
I think somebody told me.
Oh, it's not in the grammar. Go back to the proto file. Sorry. You already have it open.
Is that one of the things that somebody told me at some point, that this is the difference between Roland and row calculus? That in Roland, you, like in row calculus, anybody can create arbitrary channel, because you can just quote a process. So anybody could send or receive messages from some channels, like could spoof and listen to things you're supposed to be listening. Right?
There is no security in row calculus at all.
Mm-hmm. Mm-hmm.
It's like impossible by design. If you scroll down, Henry, to the very bottom. All right, there you go. So message gprivate. So that is a process, or gprivate, it can be added to a par. Gprivate is basically a process that cannot be constructed from the grammar.
I see.
And right now we construct them as GUIDs.
So system channels will be quoted gprivates.
Yes.
Okay.
And so what you'll...
Can we quickly look at one more time a definition of channel, just very quickly, like above? Like, Henry, can you scroll up? Just so channel is one of it's okay. So it's either quote or some var, whatever var is. But I understand, and so par has gprivate. Okay, as ID. Okay, IDs. Why is it called IDs? Because
They're just like the GUIDs right now, that they're like, it's a list of these G privates, right?
Yeah, and so gprivate has a string right now. Into the implicits, if you build one without arguments, it fills it with a UUID.
okay. And how does Powerbox, like, why do we need Powerbox, like, as a concept, like what that would be? Because for now, so definitely I'm not understanding everything correctly, but the way that I see it for now, and correctly when my understanding is incorrect, is that we instantiate. So when we instantiate the interpreter, we push a tuple space, but that tuple space will just push some channels to it, and those channels will be private G private channels. I mean, build on G private channels, G private processes, and then we will store continuation. So, for example, let's talk about a standard output, right? I can push a continuation that if somebody will send a message on this G private channel, then I will print out this thing to the console, and this will be Scala continuation, right?
Yeah.
Where does the power box kicks in? Where is it? I don't see it. I don't see
Okay, but you just built it. The power box is okay. So let's just deal with just standard out because it's easy,
Sure. Yeah.
right? You add a process that's listening on a private name, and if you write to it, it writes to standard out. That name is the power box.
That name, the private name. So
The private name is the power box because owning or having that name gives you power, specifically the power to write to standard out.
Okay.
And so this is valuable because you could take something that you could write a process that was listening on a public name that that you know some contract on a private or that had a handle on the let me see if that has a handle on standard out, and so users can call this other thing that happens to write to standard out, but they can't write arbitrary things to standard out. So you can attenuate standard out.
I see. Okay. So I don't know how much time do we have, but wouldn't that make sense right now if the step that we would do, we can actually have a PR out of this pair programming session, and so this is what I'm thinking. Right now, the consume method and produce method, the continuation that they take, it's only it's only a pair, which is a rollup stuff, right? But we will have to make it to receive either a Scala continuation or rollup continuation, correct? Is it?
That's my understanding, yes.
Yeah. So wouldn't it be beneficial if you just make a change like that? So just the change within the interface, so the consume method and produce method, that they will actually have ability to read also Scala code, not necessarily interpreting it yet, right? There's let's say if you have Scala continuation, you don't run it yet. But just to change the interface, and having that, then we can a next step would be providing a standard output continuation. Would that make sense right now, or is it too?
It's a little bit ambitious.
Ambitious, yeah.
Yeah. Yeah, but that's what I was saying. That unless you have something to. Unless we have the ability to store different types of continuations, you aren't going to get very far with a power box implementation. Right.
I mean, no. I mean, would it be okay? So let me clarify. I don't need it yet to be working. I just need the interface for the consume method, right? To take the Scala continuation. It doesn't necessarily have to know how to interpret that yet.
Okay, well, if we just riff on this idea a bit, the idea here is that instead of the store being instantiated to take a par, here it's going to be taking some new tagged continuation type. We can't define that tagged continuation type in Scala. We're going to have to do it with protobufs because it's going to have to be serialized the same way that a par is currently.
Sure.
So let's go ahead and...
Well, no, you need a serialized instance for it. I mean, you could write a tagged continuation.
Yeah, no, I mean, well, yeah, that is correct. It would seem to me that would it not make sense to also do the definition of a tag continuation in protobufs as part of, or not?
Well, that depends. If you're going to try and write the actual continuation out to disk, it might be harder to stuff that in a proto.
I'm not planning to write the actual continuation. I think.
Okay, yeah, then you can just make it a proto message worth a one of, right?
Yep. basically the idea. Okay.
And the
So,
Scala continuation, you just want like a key, an opaque key, or like an int64 key.
Mhm.
And
Okay.
then
so if we talk about what a continuation can be now, again, it's a one of.
Yes.
Oh, we should put. We're going to put a tag in though. Isn't that right? Yeah.
yeah, one of it will tag it itself.
Thinking about this, do we want a separate tag field, or we just want to use the one of machinery?
Just use the one of machinery.
Okay. So one of, and then we'll call this cont, and we'll say par. It's our one guy. Oh, par pat.
Yeah.
And the other guy will be our scont. And that will be 2. So you were saying like a single int64?
No, instead of doing scont, I would just do int64 as scont.
Even cheaper. Cool. Okay. We'll do a little code gen.
Well, I have to say, scont is so self-explanatory. Like, I would see scont, I would immediately know what it is.
Cool. I'm glad to hear it.
Okay. So a quick question, really quickly. So, like, what was the final decision? Like, who will be responsible for running this stuff? Will that be interpreter? Because interpreter is running the Roland part, right? But what about Scala part?
Well, so
the interpreter has to do something with it when it gets a Scala continuation back. So we might separate the responsibility into something that we loving or.
Oh, so that's where the dispatcher kicks in, correct?
Yeah.
Yeah, and so
Okay.
if it's a Scala continuation, we dispatch it to the bit of Scala code.
Sure.
If it's a par, then it just goes through the rest of the normal eval process here. Right.
Correct.
So this is like where there are some like design choices. One is we just sort of inject a dispatcher into the existing interpreter for doing that. The other one that I threw out there was, and Kyle also seems to be talking about, is if just cracking out the whole sort of evaluation machinery into a separate module. But the dispatch table itself and like the dispatch code can still be sort of separate from, it doesn't have.
I think it's good. Yeah.
Yeah. So, all right. So if we're going to be back in here, and we're going to have our models. So then when we instantiate the store now, our continuation type is now tagged continuation.
Mm-hmm.
We can write a serializer for that pretty easily rather than having to do a par one here. We just hand that little guy over to our Mook protobuf instance.
Oh, cool. I was not aware of it.
Mook protobuf instance generates type class instances based on the fact that there's like a super type for all of these Scala PB protobuf messages. So, yep.
That's pretty cool.
That was a Yaroslav invention. All right. So now we no longer have to talk about tag continuations in any fake way, nor do we have to do any of this stuff.
Yep.
So again, I guess here a good question maybe to ask is how are we going to construct these private channels from this side of the fence?
So in this case, you would need a dispatcher, right? Like, and so you would preload the dispatcher with some Scala function and a map of Scala functions. And
that part makes sense to me. I guess the question is the channel that we're going to consume, that we're going to put this thing on. Yeah, like for the standard out guy, for example, we'll use him as the first thing that we're putting in. Yeah. That stood out channels, if I understand correctly, that stood out channels is going to have to include these G privates. And you talked something about there being, how do we construct channels on this side to be those private names? Yeah.
So go to the interpreter implicits file.
Mm-hmm. These implicits.
Yep. And then if you go and then look for G private in there.
Okay.
Okay, keep going. There we go. Object G private. Apply.
Oh, okay. So it's pretty much as simple as just constructing one of those bad boys over here.
Yeah, if you just apply, so the giving it a string is for testing.
Mm-hmm. Okay.
Eventually, we want that to be cryptographically secure. I don't think random UUID is cryptographically secure.
What would Mark Miller say? All right.
Have you met Mark?
I have not. I'm just familiar with his work and know that Mike has worked with him. So, yeah.
So the cryptographically secure is to avoid overlap, is all. Right? Like, if the system is functioning correctly, you can't create these. But maybe what you could do, if they aren't cryptographically secure and you've got some rev to burn, right? Like you can just create a bunch of new names and then see which ones get created. And then if you hit the jackpot, you can, right? Because you can actually inspect which names you have. Like, so
right.
If there's only 32 bits, right? Like maybe you can just spend a bunch of rev and like generate all the random UIDs.
Okay, I have a lame question here. So when you guys are talking about like this being cryptographically secured, you're saying that UIDs have a pool of possible values, which is just too small, right? Like we could duplicate values. Is that correct?
Yes, that's exactly what I'm talking about. So random UID, I'm pretty sure uses system.random.
Yeah, okay.
And what we want is java.util.uuid.cryptographically random UUID.toString. That's all.
Okay.
So this is creating a G private, and then what's the machinery to wrap that up to make it
I think you just like it's implicit, right? So you will just say
yep. No.
I have to put it in something, right?
Yeah, there's an implicit from G private to par. So just say quote. And there's an implicit from quote to channel. So quote G private.
Still needs to be a list. Got to get those implicits. Oh, wait. Is that the right quote? Looks like it is. Oh my God.
That is the right quote.
Fantastic. All right. So instead of calling this G private, let's call this stood out channel.
And then the patterns are going to be list of So it's going to be a list of size 1.
Mm-hmm.
And it's going to be the following of a seek of size 1. Although we could, seek of size 1. And then it's going to be chanvar freevar 0.
Chanvar dot freevar?
No, and then of freevar of 0.
Of freevar, chanvar of freevar?
Yep.
Of
0. Yep.
Okay.
Okay, could you explain what just happened?
Okay, sure. So the pattern language and the process language are the same language, except that there's certain things you're not allowed to do. If you're trying to write a pattern that you want to be run as a process, there's certain things you're not allowed to do, which is, at the moment, you're not allowed to use wildcards and you're not allowed to use free variables. That's why list of channel is the patterns, just because the pattern language and the process language are the same.
Okay.
So this says there's 2 ways to build a channel. One is to build a channel by quoting a process. And the other is to build a channel by referencing some variable that holds a name.
Okay.
And in this case, the variable that holds a name is a free variable, meaning that it's not referenced by anything. If you were to write it out, you'd be writing. Well, because of shadowing, it's always a free variable.
Sure. So it's could we really quickly just do sort of like in comments how the Roland code would look like when I'm sending a message to standard output? I mean, I know it doesn't exist yet, right? But how that specific Roland code would look like, which would send a message to standard output, print out this thing.
It's like, do we say at system or just system? Kyle?
What?
Do I do at system? Is that right?
What is system?
That's the system channel?
That's a variable name. So if you want to
It's like the system thing that's injected at the top of...
Pawel asked what the syntax is in Roland to send something to standard out.
Okay, so if you have the standard out channel, it would be standard out channel bang thing.
Oh, it's standard out channel. Okay. So far in other discussions we've had, Mike was talking about just having system bang thing.
Oh yeah, you can call it system, right? But system, so. But if you look at the way he talks about it, he talks about contracts receiving system.
Right.
So they're going to build something more complicated than this. But we're just going to build a process that gets a handle on standard out.
Okay.
So it's just going to be standard out bang, and then some string, like hello world.
Okay. So I'm trying still to understand, I understood patterns in terms we are sending only one thing, right? So
yes.
Oh, okay. So the standard, so the patterns here are saying we are only interested in one thing, and free variable is just that we don't. At this point, we don't really care what it is, right?
Well, it does 2 things. We don't really care what it is, but we could do chanvar wildcard, and that would also not care what it was, but it would not make it available to the continuation. Freevar does 2 things. It's slightly less powerful than wildcard in ways that are subtle, and but not at the top level. At the top level, it's just as powerful as wildcard, but when you it becomes less powerful. It says that we care about the argument. So the standard out continuation is going to you can tell from the pattern how many arguments you're going to get.
Sure.
So in this case, the dispatcher will know that it's going to get one argument, and it's going to take that argument and apply it to the function.
Right. Right. A wildcard would say, what? I don't care about how many arguments. Like wildcard, like.
No. Wildcard says I don't care about the contents of this particular argument. You still have arity matching, even if you have a wildcard.
So that's RT1 still, right? Like the wildcard. That will be char var and then wildcard, and it still would mean one argument. I just don't care what that argument is.
That's right.
Okay.
Remind me how I construct one of these bad boys.
Well, like instance? I think it's a case class.
Tagged cont? No, remember it's a one of, so that's like there's either a par or a scont.
Oh, so there's like a message, but you can go to tag continuation. Go up. The tag continuation. No, I'm just the Scala code generated.
Oh, the Scala code that's generated.
Second tab. Go up. Up. And that's a case class, tag continuation, that has tag continuation count, which is a method, which is something defined below. And like if you go scroll down, there it is.
Empty par scont, right? So we can say like tag continuation. Was that right? Did I just see that? Oh, it's cont.scont. Cont-scont. And then one.
Mm-hmm.
You hate that. No, you don't. You do. You're good. All right. Thank you, Hector. So now we have our cont in there. And it's still whining about what I've done.
What have you done?
Yeah. His name is Hector because he's hectoring. Hector the Inspector. Yeah, I know, guys. I've written cannot. You just don't like that? Is that what it is?
That would be stupid.
It would be very stupid.
Can you show consume really quickly one time?
Come again?
Could you show the content of consume, like the?
Oh yeah, sure. This is the implementation of consume that's in the actual RSpace code.
Mm-hmm. Okay, so.
So we search the store for data matching all the given patterns at the given channel.
Oh, okay, and it works because your RSpace is sort of parametric in the time. So you change the type of continuation, right? And it magically works.
Yep. Continuations only have to implement serialize. We don't care anything else about them, right? Yeah. Those are the two type classes that drive the whole thing. Are match and serialize. So, you know.
But now the Roland compiler probably won't be happy because he's expecting a different type of tuple space, right?
Yeah, that's correct. If we were to pass this store into the REPL right now, I mean, like, and try to use it as a REPL, it would bomb out. Probably wouldn't even compile.
So why isn't it? Like, because you were changing that build?
Oh, well, so here you can see I've already changed the instantiation of the store to take one of these tag continuations.
Yeah, but that
trivially produce the serialized. I haven't actually run the compiler yet, so if you, yeah, we can do that.
And then you'll
watch the
exception. Yeah, if you run the compiler, it will complain when you try and pass that store.
It's where build store, you know, is returning its store. Oh my God, nullery side affecting methods here. This is no good.
Yeah, one day we'll have a a warning party.
Yeah, I started that the other day, and then I was like, I'm not doing this right now.
Warning party. Warning
I was waiting for Travis, and I was just like, could go and hit all these warnings. Let's start that.
And then I could just go cry in the corner instead.
Oh, I feel bad because there's all this stuff in Rose Scala that I don't want to touch, you know. So,
well, I can touch it. I still don't want to touch it. No.
oh, the code gen is stale. You're gonna have to give me a second to do the code gen.
Yep.
Sure. So Kyle, my question is why would it be a problem right now just to only change how big of a deal is right now just to change the signature so that the interpreter takes the new tuple space with that new definition and you completely right now ignore all Scala continuations, you ignore them. Would it be
that wouldn't be that hard.
Because having this, we can have it actually at least some initial PR that we could merge to dev at this point, right? This is the boundary I was hoping to get, between Roland, tuple space, and the continuation, so the PowerBox stuff.
So here's what I see. Assuming that we don't want to crack out the evaluator into a separate module as part of that, then what we need to be able to do is hand in this kind of dispatch table, even though it will be basically empty in your view.
Well, right now we can just ignore it, and then later we can add the.
Yeah, sounds good.
You can do whatever you want, basically, right? You can refactor the hell out of it later on, but that will already be in the code base. So that will allow me to do, whatever I'm supposed to do, right? And if you do some changes, like extract a module or whatever, you will have to do it and still have my already written code to compile. That's what I'm saying.
That's right.
Have just this boundary between modules, and that's a contract that we have at this point, and that will be awesome.
That's right. We could consider, at the very least, adding. How is the evaluator getting constructed after we build store? Yeah. So when we do make interpreter,
yeah,
we could consider passing in this dispatch table.
Yes.
Yeah. Kyle, does that seem reasonable?
No. Not on.
Not right now. So So we could pass in the dispatch table. But eventually, I'd like to pass in a dispatcher.
Mm.
But
we could mock out just as easily mock out a dispatcher if that's what you want. So
yeah, I'd rather mock out a dispatcher. So
okay.
The dispatcher.
Why can't we just simply a function takes an argument, an integer, and returns a task of
So so here's the thing: the dispatcher has a handle on the evaluator, and it has a handle on the dispatch table. And then when you get a continuation, so let me see if I can explain why. So if you write more complicated things than just standard out, which are just purely side effecting, you might want to write Scala continuations that call produce or consume and get continuations. And they'll need a handle on the dispatcher as well. And the dispatcher will when you get the continuation, the dispatcher will go, oh, this is Rolang. I hand it to the interpreter. Oh, this is a Scala continuation. I look it up in this table and I call it. Okay. So that it avoids the n squared problem, where every kind of the evaluator has to know about. Right now, it's not that big, right? Like the evaluator would have to know how to run Scala continuations and Rolang continuations, but the more complicated Scala would also have to know how to do those two things.
Okay.
And so we don't want that everywhere. We want it in one centralized place. You get a continuation, you hand it to the dispatcher, and the dispatcher figures out what type it is and then hands it to the right thing.
Mm-hmm.
Couldn't that be implemented as a type class? So that's becoming something that's outside defined? And I just want to avoid effectful functions. That's what I want to. I would really like to write tests for the stuff that we will be doing with continuation. But yeah, okay, let's work with whatever we
So Kyle, by your model then, am I hearing you right that that it won't make sense to have where's my reduce? To have like dispatch wedged in here in the interpreter?
The interpreter should know about the dispatcher, so that when you get a call to consumer produce
Right.
and it returns a continuation,
Mhm.
instead of calling continue, what it will do is it will call dispatch on the
Right.
continuation.
Right.
And so the dispatcher will have a handle on the evaluator.
Okay. The dispatcher itself will also have a reference to the interpreter,
To the reduce instance.
Yeah.
Okay.
Okay.
Okay, so just out of curiosity, and I'm shutting up. Couldn't we like eval and all those functions instead of returning a task, returns an arbitrary f, and then you could have a type class like dispatch or something like that, sort of the MTL style way of doing things, and then you would get that dispatch method out of the type class instance, and that type class instance would be defined, externally to evaluator. So you would have access to everything.
I mean, it's not to say I'm opposed to like, I think it's sort of a matter of getting from point A to point B here, and I mean, are you
not right now? I'm just I'm not saying right now because that would be tedious of changing all those methods here.
Right, because we're pretty much, we have a concrete monad and we should stick with it, right? Yeah.
So is it something? Okay, maybe. Okay, so this is maybe something for some other.
It's a larger question, and one that has to be posed to Kyle is: does he want to write to type class constraints rather than concrete instances, or
Okay, so we can leave it as for a separate conversation, I guess.
Right.
At the moment, I want something that works, and then you can hand me something later that still works, that uses monads.
Well, just to say, I mean, are you familiar, Kyle, with like that style of writing MTL where rather you have your arbitrary M and you write to monad reader RM, where you have like has environment R, and then so you construct these.
Yeah, I am familiar with that.
Right.
I love it in Haskell.
It's kind of hideous in Scala, is it not?
Yeah, like I want it, and also like I find that like, when I try and write Haskell and Scala, I bang my head against the wall for days, or for hours. Days is, for hours trying to figure out like why this perfectly reasonable thing that I translated, right? Like I made sure it worked in Haskell. I typed it out in Scala and it didn't work. If we were doing,
you're definitely the one among us who seems to be most capable of writing MTL style.
So let's work with the dispatcher one, and then maybe I can like propose a change, and we like with a pull request, right? It will be easier to talk with code, not even if it's not compiling, right? Like just to give the initial stuff. But for now, let's work with the dispatcher.
So if I say something like dispatcher body here, where dispatcher would be something that would have an apply method, right?
Sure.
But that is I thought it's something you provide to reduce Scala.
Yeah. So it's something that has to come in through the constructor.
It also needs the environment.
It needs the environment as well. So you're saying when we say.
So yeah. Well, let's see.
I'm just trying to take the continue model and replace continue with dispatch here.
Yeah. Does when we get continue, are we building the environment? I'm trying to remember. I think we do. If you go up and look at consume.
Okay.
Yeah. Do you see that call to env.makeenv?
Mhm.
Which line? Which line?
Here,
Okay.
So we'll have to change that because you only really want to make the environment if you're going to evaluate it as a rolling term, right? Like the list of data that we get back, some continuation data list. So but anyway.
so potentially what you're saying here is that it would make more sense to perhaps dispatch right here continuation data list.
Yeah.
Yeah. Yep. Heard. Dispatch apply or dispatch. Okay. Look, guys, Apple concurrent. What's that? All right. So if we have our de Bruijn interpreter, it gets a tuple space. It's also going to get something called a dispatcher. And that dispatcher is going to be a dispatcher. What is this dispatcher? Well, and where will we put this dispatcher?
It doesn't really matter right now. And for purpose of this like pull request, it could be anywhere.
Well,
right?
So it makes currently it would be something that would make sense to actually put in. It's kind of weird, but we're going to put it in Rolang for now because Node depends on Rolang. If we put it in Node, we'd have a circular dependency. Can you do circular dependencies in Scala? I try to avoid them, but
You can, but I think it's suicide. But what I'm saying is like it makes sense that actually part of Rolang, right? Like this is where you construct it. Like,
Yeah. So it makes sense to have a dispatcher like Rolang CLI makes sense still with this.
right.
Right. Like the
All right,
Rolang CLI might preload its Powerbox differently than what we preload it for Node. Right. Like we'll put some communication functions in the Node.
okay, so what is Rolang CLI? I thought it was just for testing purposes.
We're never going to release it, but it's eminently useful.
It's just roughly the same thing that's in REPL mode.
So that okay. So this is what I wanted to. This is what I was asking at the beginning of this conversation. Could I move? Not necessarily. I'm not talking about this whatever we're doing right now. I'm talking more in terms of having like one single code. I just called Rolang CLI from Node, right? Like because this is basically the same thing.
Yeah. Factor out all of the shared functionality, and yes, you can call it.
That's what I was saying. Yeah.
So yeah, like I said earlier, mail me a PR and I'll prove it.
When you guys say read body, is read body a continuation here? Yeah.
What read body?
Yeah, in your reduce trait here, B is the type of a read body, and I see par in two places. It's obviously not the type of data in the environment we're looking for, but I'm trying to parameterize dispatcher over continuation just to keep it, reasonably generic here. So I don't have to, obviously, but idea being that we would perhaps.
Yeah, I probably need to adjust that type class. But
okay.
Like Joe gave me a snarled hairball, and I just.
I know, man. I was there. I saw it. All right. So this is just going to be some type K in my parlance. And it'll be tagged continuation in the actual thing, and this is going to be some type of data, which is going to be seek of channel.
Yes.
Yeah. So KA data list.
Although you can just make them par. That's what I did.
Okay, so dispatcher will be a dispatcher of tagged continuation par.
Yeah.
Okay. And then down here, this will be dispatcher Not capital D, but little lowercase d dispatch. Okay.
Wait, why par?
Well,
That's the data.
Is it really, though? Here it's a list of secret channels, so we might have to actually make it a list of secret channel just to keep things compiling.
That's fine.
You know, because a channel is a par is a par. So, and then this guy, all this guy is now going to go into this dispatcher, whatever this dispatcher may be. Or no. If would it really, am I right here that consume, where do we, when we call consume you, then go, where does our continue guy get called from? Let's get rid of this. No. It's eval, right? Right. Okay, so I need a little bit of advice here about like where you see this going. Is dispatch returning something? And if so, what is it returning?
A task of unit.
Task of unit.
Okay. That's okay with me. The question is, this stuff, when we produce right now, we expect that this is going to return a task of option of cont to par, right? So, I'm sorry, consume. Same return type though. When we expect that this is going to return a task of cont to par. So calling dispatch here is not quite the stuff, is it?
Oh, okay.
No. Yeah, so we would split it out. So right now, consume is split. We'd have to split it different. That's okay.
Okay. Is it something that we can potentially do here now?
So if the dispatcher is going to do all of this, then that should just be dispatcher, the val new env, task.pure. So the type of consume would change to task of unit. And then it would just and then the none down there, the case none becomes task.unit. No, you don't even have to do that. You can just do task.unit. There's
a task.unit.
Yep.
Very nice.
And then the rest of that body, save it somewhere, but you're going to remove that. And this, you're going to have to do something similar with produce.
Let's go and just... something similar. Yes. I lost my dispatcher there. Dispatch. Body. Par. Data list. I see flashing. Meta has a question if anybody wants to field it while I riff
Wait,
over
what?
here.
What?
Over the-
Look at the chat window.
yeah. Okay. So then, does that make sense? That now makes sense, which is cool.
So Meta, the way it will work is there's going to be a different continuation. So there will be a different channel for communication which we'll create, and the continuation that will be stored will be doing that work. Like, for example, giving you a list of notes, or and then we will have to send a message back to the user on the channel.
Ooh-wee.
Which is
It sounds like communications will need to call the tuple space function
Yes.
reduce, right?
Because sending a message on a channel will be just pushing that message within tuple space on that channel, and that's it.
Sweet. Excellent.
That's I think as I understand it.
All right.
I'll just call produce, right? I will call produce on that channel that user asked for with the data, and that will be it.
Yep, that was my understanding before. Awesome.
They're not unifying correctly yet, guys. Where else could I have screwed here? So my iStore, this is definitely right. That's the continuation type in the iStore. I've changed that from par to tag continuation. Similarly, dispatcher, it probably has to do with reduce here.
Yeah.
So let's give that a little whirl there. Look, guys, a critical security update to Datomic.
What's Datomic?
It's this database written in Clojure, used for a lot in the Clojure community. It's actually a lot like Special K, in a funny way.
It's a lot like RSpace.
A lot like RSpace. Years ago, I did a little bit of Clojure, and now I'm just stuck on some mailing list.
I was telling you can get yourself unstuck from mailing lists. You just get off the mailing list.
It's just I get emails so infrequently that I don't even notice. But now, okay, so anyway,
What's the data list in this?
We're almost there. I believe that this par in reduce here is still problematic, that we essentially have reduced.
My question was on line 57, you dispatch with data list.
Oh, you want to know what the type is?
Oh,
it's
yeah.
List of seek of channel. Yeah.
Okay.
Or a par.
Seek of channel. Okay. And
No. Go back up to.
No, but that's the thing. Like, you have a list of sequence of channels in dispatcher. That's how we instantiate it, right? That here, that data list is just a sequence of channels. Just go to the data list, line 57.
I'll get there. it's not complaining about data list right now. It is complaining about.
So no.
So
I can see the problem.
Yeah.
To par. Where your cursor is.
Yeah,
Change that.
to par. You cut out there for a second. Okay.
And then in the arguments to consume, the body needs to be a tagged continuation.
Okay, that makes sense.
So the receive
Yep.
error when you're calling consume.
Magic. All right.
So we'll have to build a tagged continuation out of a par when we evaluate receive.
Yep. Cool. All right.
I have
So
one question to clarify. The dispatcher is meant to run return Scala continuations, right?
it's meant to run both Scala continuations and Rolang continuations.
Oh, okay. And that's a change from what's happening now. So now are we supporting continuations at all, like the running of continuations at all in Node.2?
Yes.
We are.
We support the running only of Rolang continuations.
Correct. Okay, so the interpreter today runs Rolang continuations. But
That is correct.
after we implement the power box, what we're saying is then the dispatcher will then run Rolang continuations, or the dispatcher will just return Rolang continuations to the interpreter for the interpreter to run.
The run them in the sense that it will give them to the interpreter to
Got
run.
it. Okay.
So the dispatcher will know the interpreter by
Got it.
name and.
Yep. Okay. Thank you.
The dispatcher will know the interpreter by name. Which sounds to me like now what we're dealing with is an abstract class that takes as an argument something that implements reduce. Is that right?
The trait's fine.
You think so?
Yeah. But when you build it, it's going to have to know the actual instance of it. We'll need to know to have a handle on the interpreter.
Okay.
Just like it will need to have a handle on the map of Scala continuations.
Okay. So, speaking of which, we're at this point where we've taken out some pretty critical code. Would it be smart of us to actually build one of these little dispatchers so that we could actually just plug it back in and get it to do what it's supposed to almost do?
Yeah. You can make the Rolang only dispatcher.
Okay. Now, when we talk about making a Rolang only dispatcher, are we talking about making a class here?
Yeah.
Yeah. Okay. Class Rolang only dispatcher extends dispatcher tagged continuation
Par.
Not quite. Almost. List of seek of channel.
Well, that's right.
Meow. Meow.
And it needs an argument.
It does. Let me get that in there. Okay. And that argument is
Environment?
Is a reduce of the correct form.
So we're just going to hard code the other guys in there. Reduce task quote par channel.
Yep.
Cool. Don't. Okay. So we get one of these tag continuations, and we have to basically now discriminate based on what is this thing? What is this thing that we have? What is it? What can we do?
There's
Oh.
this or something like that.
I think it's .cont.
Continuation.cont. Can we then match?
Yep.
Okay, cool. Case There's something, and that something will be a remind me par. Now, can I do do I need to do a destructuring match here, or is this?
RonTypes.proto, I wouldn't call that par because I think it capitalizes the names and you're going to have a bad time.
You wouldn't call this par?
So in RonTypes.proto, no. I wouldn't call that par because it's going to capitalize that and you're going to have a...
Oh, good point. What should we call it?
I would call it par body.
Par body.
Par underscore body because that's what...
Right. We're back in...
Well, if we have cunt, should we have like par cunt? Like...
it won't be par cunt, but it will be maybe Scala body.
Scala body. Fair enough.
Scala body ref.
Yeah.
Beautiful.
Something will break after.
Yeah, and then you can do par body of P, and P is a par.
Par body of P, and P is a par. You're talking about in the code that I was just reading.
Yeah.
Yeah. Okay. Reduce. I gotta wait for the code generator. Otherwise,
well, you can write it out, and it'll be right when the code generator.
When you're saying it's going to look like what here?
It's just a case class that contains a par. So case par body of P.
Really? Like that?
Yep.
No kidding.
You sure?
Yep. Go look at the eval code down below. You'll see.
I trust you. I don't need to go look.
So like the eval expression is a good place to go.
It converts snake case to uppercase camel. Sounds like what you're saying.
So like if you go look at eval expression, you'll see.
Eval expression. You're talking about...
So expression.expression instance match.
Expression.
So then like E naught body, E naught P.
Oh, okay. And those come right from...
Yeah.
So this is generated by protobuf? Like
yeah.
Well, Scala, it's Scala PB. I don't know. Is that also a feature of the Java protobuf thing too? That it converts.
Well, they don't have case classes, so I guess not.
Who do what?
They don't have case classes, right? I think it's only like an apply. It's like a pattern matching thing.
An unapply. Yes, very good. Yes, thank you, Pawel.
But it just actually generates case classes for the...
Still not happy.
Oh, you need to import it. There you go.
Okay.
But I was not aware of it. That is pretty cool.
Par body. Scala body ref. Or I or L.
Or ref.
Well, yeah. I'll do ref. Make your life easier.
Yep.
And I'll do par. Okay.
So then that throwaway code, you can make it either like a helper method in dispatch, or you can write like...
It's the same for both, is it not?
It is the same for both. So
Yeah.
this is reducing redundancy.
Yep. So we'll call this like create env, or make env. Well, it is.
I would call it build env.
Build env. Doesn't take anything. Does take something.
It takes a
data list.
A data list, a list of seek of channel.
I really gotta
and produces an env par.
change the tuples base to use seek now. My insistence on sticking to lists to keep things simple has only caused an unfortunate propagation of types like list of seek. I guess nobody wanted to follow my example.
I used list at first, and then Protobuf used seek everywhere, so I was like,
and vector. Yeah.
Well, yeah, but it doesn't tell you what it is. It's just a seek or a seek.
Right.
So if you just build one, it produces like if you just one of the case classes, like by constructing it, it produces a linear seek, like an immutable seek, like a list underneath. But if you serialize it and then deserialize it, you don't get back that. You get back a vector.
So obnoxious.
So for the interpreter, we actually want those to all be vectors because that will allow us to do things like efficient nth access.
Yeah, I haven't ticketed the work yet, but I'm actually planning to see if I can get Yaroslav to do that for RSpace this sprint. That'll be part of the 0.2 release of.
So wait, do you want to switch from list to seek?
In the RSpace, I just want everything to be seek. If we're going to be doing trafficking in seeks, let's just do seeks.
Yeah, I need to make smart constructors that or make smart constructors that when we build the new things pop in the interpreter, so like we build a new par, that it populates it with vectors instead of
I don't know if it helps, but you can, when you're making a class, you can make this constructor private, and then you can put a smart constructor in the companion object. So that's actually ends up being very helpful in some cases like that. Don't know if it helps in this case, but all right. So we've got our end, then our par body. We've got our data list, so we're going to take that. We're going to get that env. And what are we going to do?
It has a handle on the interpreter, right?
Yeah, so we got to call reduce.eval. Is that right?
Yep.
And I'm just going to hardwire that in, Vin, because I'm feeling really good.
Yep.
Yep. Okay.
Don't you need braces if you have val and then something else?
No.
Okay.
Implicit. A lot of people do that just because, and I don't begrudge them that. I think it's a perfectly fine thing to do because it's sort of like, mandatory braces on ifs and if else's, right?
And what about consume?
Come again?
There was a throwaway method. I think
They're the same.
They're the same, so we can get rid of them both. Yeah. Yeah. Varu. We got a Varu.
I think I changed it. Change it to valproc. You can just fix that while you're here. My editor doesn't highlight crap like that.
Yes, I know. It's actually a much calmer experience editing in Vim, isn't it?
Yeah,
like trigger all those like Pavlovian responses. Oh my God, what's the red? Oh my God, what's the red? Yeah, that's what I do after I retire for the day. Is I go hobby hack in Vim and Haskell and feel calm.
I was once on this interview for this company in London, and I was being interviewed for a project in Scala, and the project leader was a Haskell developer. And we're having this conversation, and he's saying, I'm like, well, you're a Haskell developer, what the hell are you doing in Scala? And he said, well, I moved to London, and I wanted to find a gig for 6 months, so I have money to pay for accommodation and stuff like that. And that was 4 years ago. like what's happening? And well, I'm sleeping on the maker's flow money. I was okay. You sold your soul. And he's like, yeah, I did.
That's not selling your soul to write Scala.
Yes, it is.
I do think it requires like adapting certain blinders at times if you had the experience of writing Haskell, right? But
I would rather take Haskell devs and teach them Scala and have them complain about it than hire a bunch of Java devs and try and teach them functional programming in Scala.
yeah.
Oh yeah.
Right? Like I would much rather just like no. Go write Haskell for a couple of years. Come back. Then I'll teach you Scala.
My experience is it doesn't really have to be years. I've seen successful people playing around with Haskell and then complaining on their daily days like, this sucks. Oh, it doesn't compile?
So yeah, I was trying to write.
I think CodeGen shat itself. Let me do it again.
If you go look at reduce.scala, you'll see somewhere where I just got mad and I just did the stupid thing instead of because I couldn't do the smart thing. If you go look at reduce eval expr, yeah, and then you scroll down, you keep going.
Is this the one?
Oh, no, the one up above.
Okay.
Well, there's more than one eval expr function.
Oh, I see.
The function up above.
The function up above for evaluating expressions. Yeah. Okay. Is it this one?
Yeah, that one. So go look over there. Do you see like there's 3 less thans and 3 less than or equals, 3 greater thans, 3 greater than or equals? Because Scala does not let you, doesn't have rank n types. So you can't pass something that will work for anything that's comparable.
You'd have to use shapeless poly, which is just like not, it's probably not worth it to be bringing shapeless in just for this one use case, but.
Unnecessary.
We have shapeless already.
What?
By the way. We have shapeless already.
Oh yeah, no, I know. I mean, it's I even actually encouraged Kent to use it to test round tripping protobuf code, because writing out, we're using Scala check to like generate arbitrary pars, and I was like, you don't want to have to write the arbitrary generators for the pars yourself. So, there's the Scala check shapeless library that like basically generates, does auto deriving to generate arbitrary instances for data types. Yeah, exactly. It's it's the guy who wrote Corsier, Alexander Archambault.
Yeah. So you'll like this. One of my favorite interview questions is, given a binary tree, construct an iterator to produce that yields the values in order.
Oh yeah, I've noticed that in your write-ups.
So one of my favorite thing though is in Haskell is if you have generalized new type deriving, you can say deriving traversable from the binary tree class, and then the answer to that question is 2 words. It's traverse _ yield.
Oh yes. Awesome.
Because in Haskell, like yield is first class, so like you can pass it all along. It doesn't, unlike in Python where like yield is not first class, so you can't like take the yield here and like pass it down the stack.
Yeah. But what was the question? Can you repeat the question one more time?
Oh, given a binary tree, construct an iterator that produces the values in left to right order.
Oh, okay.
It's actually a really good question because...
What do you mean by iterator? You mean like the Java iterator? Or
Scala has one too. Yeah. It looks like the Java one. It's just got a bunch more methods.
Okay, so like a next, one of next and as next, something like that.
Yep, exactly that. I've had Scala devs complain to me that this is mutable. I was like, okay, fine. Then do a next that's immutable, that just returns a new iterator and the value. Like, and they still choke.
Oh, fuck. What is going on now?
Rosette?
Yeah.
Are
You didn't
they,
break that.
No.
Are they dependent on each other?
All right.
One thing I know.
Just do Rolang/assembly. Like,
yeah. Well,
I never have time for that noise. I never compile anything but Rolang.
no, this is,
Yeah,
I sit here looking at every project compile every day, but
Keith is splitting out Rosette and the compiler, and that's
yeah, no,
location
that's some transient thing that's happening to me here today, and probably need to do a little.
Maybe just I think we are touching actually the node as well. So maybe just do node assembly.
I will, but I think what I'm going to do is, I mean, I can just rebuild project there, but yeah, node compile.
Busy.
My muscle memory is like, to
Compile it all.
To just run the control F9 every time, and it has dire consequences.
See, I taught Vim how to just run SBT, and so I just make Rolang compile.
Yeah. You want to know here? Let me show you something that I wired up for Vim, and while it's compiling here, you might find this fun. It's an SBT quick fix. Yeah, there it is. All right. So this is a wrapper that I run around SBT using T, and it parses. I put it in continuous compile mode, and it parses for compile errors and then writes them out to an errors.error file so that Vim can find them with quick fix mode. So every time if you have to jump to the next, compile failure, you can just do :cn :cn.
Yeah, there's an sbt.vim file that you can do that.
Yeah, this is basically an adaptation of like a shell script. Actually, in fact, somebody had already started to write a Haskell version of this, and I went and I borrowed his code and improved on it a bit. So, yeah. So when I use Vim to do Scala stuff, then I just wrap SBT and have it spit out the errors.error file.
compilation's done.
Thank you, Meta. Keep me on track.
We have 6 minutes before time is up. I mean, we could theoretically go over, but I think Kelly has to take off.
Yeah, and we also need to shift based on the things we learned today. We need to shift and look on what the planning is for the April release.
Okay.
Yep.
Are we ready to do this?
I mean, I have all the knowledge that I needed from this meeting. Like, this was awesome for me. Are you asking in terms of the scope?
Like, we're about to get into like the nitty gritties of the fact that we're now trafficking in tag continuations instead of pars. So
I can tell you what's going on here. So the produce function needs this loop instead of the eval. So it's just going to do it would be underscore from produce yield yield unit. And then this loop right here needs to go in the produce method, because the produce method is what's calling dispatch now.
Mm-hmm.
So eval becomes less complicated and produce becomes more complicated.
Okay.
And I'm going to sneak off.
Okay. There's like going to be I'm sure there's still some more questions that need to be answered about, because that's not the only
Yeah.
thing that comes up there. So
We should gather up all the questions, then we can have another session with Kyle. Kyle, you're going to cut the release, right, after this?
Yeah, I'm gonna drive in and cut the release.
yeah, Kyle, we also need to talk about doing the sonotype push for RSpace today. Yeah.
Okay.
Okay, so ping
Did
me when
you,
you're.
Kyle, ever get information on how to sign the package? I don't know what went down.
We'll take care of it at the office. We'll be
You
fine.
have keys now, I take it.
Yeah, Nash generated like official PyroFX keys,
Right.
and I'm gonna cross-sign them with my low MSD key.
Now, when I talked with, just take a minute here. When I talked with Nash, he talked about having a root set of keys and then and then an additional pre-production set of keys that would be signed.
Kelly, do
by
you
the
want to
root set of
stop
keys.
recording, please?
Very much so.
Thank you.